variance. We write v and then one more line. The variance of a random variable x is the expectation of a function of x where this function is the variable subtracting the expected value and then the whole thing square. Variance is standard deviation square, or standard deviation is variance square root. You can think of it like this. So suppose x denotes how much oil a car will burn, then x has a unit. Let's say the unit is liter. Then that means x has a unit liter. But in this operation, there is a square. That means variance, we have a unit of liter square. So x has a unit liter, but variance has a unit liter square. You cannot compare liter with liter square. That's why taking the square root will turn the liter square back to liter. The reason why there's a variance and also a standard deviation is that with variance, you cannot compare directly with the x or expected value, but standard deviation you can because they share the same unit. Here's an example. Suppose the random variable x takes the value of 1, have half of the chance. The random variable x takes the value 2, have 0.4 the chance. And x takes the value 3, have 0.1 of the chance. And let's say the expected value of x is 1.6. Then what is the variance of x? It will be every x subtracting this expected value, take the square, and then take expectation. That means every x, that means the 1, 2, and 3, subtracting this 1.6, so 1 subtracting 1.6, multiply the chance of 1 occur, and then plus 2 subtracting the expected value, take the square, multiply the chance it occur, plus 3 minus the expected value, take the square, multiply the chance it occur, it will be 0.44. And here is a very useful formula. The variance of a random variable x equal to the expectation of the squared random variable subtracting the square of the expected value. So here's a proof. By definition, variance of the random variable x is the expectation of the x minus the expected value and then take square. Then what's next? We expand this bracket, x squared 2xex plus ex whole square. And then recall that expected value is linear, so we can distribute the e into each of the random variable. So I get this thing. So for the middle term, this ex, this is a number. We can take it out on the e. So therefore, this 2 and this ex are both numbers. We can take it out, so we get this. Lastly, this is the expected value of a number square. So we can ignore this expected value and take this number square. So we have this thing. Notice that there are minus 2 of the ex square. This is plus 1 of the ex square. So these two will cancel out and give us this. So therefore, Vx is e of x squared minus ex whole square.